We are the G Project Group. I am Shivani Patel, and this is Genmark. Our mentor is Dr. Epstein. So our goal is to modify and update or improve any of the experiments that need modification in the first semester physics courses. The one that we have done so far is uniformly accelerated motion, calculation of G, the friction experiment, the conservation of linear momentum, and eventually write new lab manual entries for those to replace the current ones.
So in summer two, we had 2 more focus groups test our experiment, different iterations. The first one being with Deepa, and that was really well. And later on, we tested with Dr. Sivo and Dr. Martin. The data collected from these groups, as well as one from the first one, is shown here. And what we found is that we had consistent values all throughout, and actually really good values from all throughout the focus groups. And what's also noticeable is that the ping pong ball, which we expected to have a lower acceleration, was the same all throughout the focus groups. Furthermore, what we learned from all these focus group testings is that we needed to improve upon our procedural steps, making it less confusing, such as how to place the meter stick. Instead of placing it upright, we placed it horizontal just to make it easier on whoever's reading it. Furthermore, we sent our current iteration of the lab to Dr. Epstein's colleagues in Fairleigh Dickinson University, and they looked at it, and they're actually going to use it for their fall semester. And so here we improved upon the phone holder just to make it a lot steadier and a lot easier for people to use.
And the second part to the experiment we just did was linear air track to measure the G. And in the picture you see here that the air track is angled at about 15 degrees. And due to reaction, when students are performing the experiment, they're given a stopwatch. So due to reaction time, it's nearly impossible to get the times at like a high degree of more than 5 degrees, angled at more than 5 degrees. So instructors were really restricted to using less than 5 degrees, but using the software that we used for the previous section, now we see that we could use a higher angle and still get pretty good results, or actually better than they would with the stopwatch. So here are the results from our trials. The blue table on the top represents the data collected using the software, and the green one is using the stopwatch. And from the graph of acceleration versus sine of the angle, you will get the experimental gravitational acceleration. And as you see, the blue one again represents the software, and the orange is the one that represents data taken from using the timer. And you see that using the software, we got 9.82 meters per second squared versus the 9.03 meters per second squared using the timer.
So during summer 2, we also looked at the conservation of linear momentum experiment. The problem with this experiment right now is that when the 2 carts collide, for example like this, it causes a bounce up, and that bounce up causes a nonlinear motion to occur, causing experimental error within the experiment. So what we're trying to do is to improve upon this by using older carts like these, which have rubber bands as the bumper. The good thing about using these rubber bands as the bumper is that the area at which the 2 carts collide is actually much smaller, so your deviation from the linear motion would be less, thus causing less error, or if not, just 0 error. And so our current task is to, as well as improving the conservation of linear momentum experiment, is to add a stopwatch calculation to our G experiment for the ball drop, just to showcase how ineffective just the human vision can see. We're also improving upon the friction experiment, trying to get a replaceable surface for that, because the current ones, as seen in the photo there, the surface is actually damaged, and so having a replaceable surface means it's easier to maintain in the long run. In the fall semester, we'll hopefully be looking at the two-dimensional projectile motion case and improving on that. If you have any questions or just want to look at the blog, this is our contact information.